So first, yeah, I'm glad to be presenting this on behalf of my team, Jeffrey, Chisom, Marek, Michelle, and Shayekh. So our project mainly focuses on instruction tuning datasets, and specifically on the Aya dataset, which has more than 200,000 samples in 71 languages, and the rows are as shown to the right. So each row has an input and then a desired target, and it's assigned to a specific language. Next, please. So with a huge data set that covers more than 70 languages, we are expecting to have some mislabeled samples. So that's an example of a sample we found in the Hindi split, in which we have an input that is, imagine a futuristic society where robots and humans coexist, and then write a scene about that. But actually, the target is a Hindi translation of the English prompt instead of a scene that's actually being described. So why is this actually problematic? Next, please. So we know these data sets are actually used to fine-tune models. Next, please. So when we queried the Aya23 model, which is fine-tuned on the data set, with the exact input, we find that first it actually spits out the verbatim targets that we had, and then it's actually starting to generate a scene, but this time in Hindi, which I assume isn't what the user would have expected. Next, please. So this kind of phenomena is studied and it's termed as language confusion. But that's maybe one more reason for this language confusion, which is issues actually within the fine-tuning data more than how sampling is being done or other reasons. Next, please. So for us to discover these samples or potentially mislabeled samples, we first discarded duplicates within the dataset, and notably a language like Yoruba has more than 5,000 samples that are actually duplicated, representing more than 43% of the data, which is a chain. So that's the first step. Next, please. And then we also decided to discard trivially short inputs and targets. So ones having less than 4 tokens. And for counting the tokens, we used stanza. So to the left, you can see some examples in the English dataset, which at least to me, they look to be trivially noisy or unimportant. And then the table to the right shows actually the languages with the largest number of trivially short samples. So you can see Tamil was 132, and then we can contrast that with Igbo, for instance, with 81. But when we actually checked both languages, we found that they are not actually the same. Next, please. So for Tamil, they have lots of short prompts in the sense of asking to translate an English term or a word into Tamil, which are the ones shown to the left. But for Ibu, actually, one of the team members can speak the language, and she also confirmed actually for Ibu, it's not the same case. These are actually trivially samples that need to be discarded. So we can use human verification for that, but we also attempted to use large language model as a judge, and for that we used command arctos. So the histograms shown below show the ratings for the samples that we identified in both languages, and you can see for Tamil. For Tamil, this is not the right histogram. As you can see, it's the same one, actually. That's an issue. Anyway, for Tamil, if you trust me, their words were actually leaning toward higher scores, while for Ebo, as you can see, it's actually the other way around. It's assigning it low scores. So that's kind of promising in the sense that we can use that as maybe one more step for verification. Next, please. And the last step was for us to actually identify the language of both the inputs and targets. And based on that, we can generate multiple splits of the remaining data set. So the first part is what we call the misplaced split. So as shown below, these are samples that are assigned to English, but then if you check them, they are not really English. Both the inputs and targets are not English. So they need to be moved to another split of the data set. Next, please. And then for another kind of issue when it comes to labels is similar to the motivating example we had initially, in which we have an input and target in two different languages, and not only that, but actually with misalignment between the inputs and targets. So the instruction is not to translate the input into a target, and then we have that. So that's an issue we can detect based on that, and then the remaining parts goes into what we call cleaned Aya dataset. Next, please. So this method is promising when it comes to actually finding inputs and targets in two different languages that need to be discarded in the sense that they're not aligned. But we also noticed that this method flags languages like Standard Malay, Standard Arabic, and Portuguese. And in verifying these, for instance, for the first one, the model was basically confusing between Standard Malay and Indonesian. So it's kind of more of an false negative from the language ID model and not really an issue with the dataset. And similarly for Standard Arabic, it was confusing between Standard Arabic and some dialects, specifically for really short targets or inputs. And for Portuguese, we also have had a sense that's the case. Next, please. So for Standard Arabic, for instance, we decided to look deeper into actually the inputs. So for these two histograms, we compute what's called the level of dialectness, which is a metric introduced to define how a sentence diverges from standard language, and 0 implies no divergence from standard language. And as you can see, the distribution of these scores for both the inputs and targets is actually mainly centric around a score of 0, which means they are indeed in Standard Arabic. So instead of using dialect identification, this can also show us if the sentences are mainly Standard Arabic. And as we can see, both inputs and targets are actually the same. Next, please. So to conclude, we managed to design an effective pipeline for flagging potentially mislabeled samples. We need human in the loop to verify these samples. And we also find that large language model as a judge or perplexity show promising results in helping with that. Thank you.